All right, so here we're going to be simplifying rational expressions and also with multiplying and dividing. So when you see a rational expression, so basically these first four problems are nice and easy because they're already factored. What you're going to see in a problem is you're going to see things that need to be factored by you. And so I'm just trying to show you what's going to happen eventually, but if it already factored, it kind of turns, makes things a little bit easier. So when you have the same when you want to reduce a fraction. So this kind of goes back to something like this. Like let's say you had 20 over, I don't know, over 24. And you sit here and you're like, I'm trying to reduce this fraction. So the way that you've done that is you've done this. You have 4 times 5 is 20, and 4 times 6 is 24. So since you know this, you're able to cancel the 4's out, and then that's why you know that 20 over 24 reduces to 5/6, right? And so it's basically what we're doing here. All these pieces, these fractions here, are broken up into their multiplied parts. And so when you see something that's exactly the same, you cross it off. All right, so 4x plus 3 goes away, x minus 5 goes away, and that's it. So what I have left on the numerator is 2x plus 5, and the denominator is just 2x. I cannot cancel these 2x's because this 2x up top is attached to the 5. They're married together. They can't do anything without each other. Okay, so this is my finished answer. Next one, number 2. I definitely see x plus 3, 6x minus 1. So now I have 12x to the third over 4x. Now, these things, there's no addition or subtraction here, so I can keep canceling. For instance, this 4 and this 12 can turn into a 3 and a 1. X to the third. Well, this x can cancel, this can leave 2 there. So when I'm done, I basically have 3x squared over 1, so that's just 3x squared. All right, and the next problem. 2x plus 7 and 2x minus 7 cannot cancel. 15 and 3, let me put 5 and 1. X squared and x to the fourth. So this x squared is totally going to go away, and x to the fourth is going to leave me 2 left. All right, so I'm done with that. So I'm going to start writing my answer here. I have 5. On the bottom, I have x squared. Now, this piece. So this part right here, okay? You notice it's kind of similar, but they're backwards. So I want to show you what would happen here. So let's say you had something like 5 minus 3, and on the bottom you had 3 minus 5. So the top would be 2, the bottom would be negative 2. And if I cancel 2 and negative 2, I get negative 1. Let's say I had 10 minus 6 and 6 minus 10. Well, that's going to be that's going to be positive 4 over negative 4, negative 1. So whenever I have the same thing, but just the reverse, I can go ahead and cancel that out and just know that it makes a negative 1. So I'm going to do that here. This cancels out, and I know I have a negative 1. So when I'm done, I have basically 5 times negative 1. So I end up getting negative 5 over x squared. And that's my final answer. So what I like to do is this. You don't really have to write a negative 1, but what I usually do when I see that, I cancel them out, and I just make a negative sign. Okay, and then you'll have to put the negative 1. All right, so last one, 2x plus 9, good. 3x minus 2 isn't going anywhere, but let's look at this x minus 6. I have x minus 6 and then x minus 6 to the third. So I have 1 of them on top and 3 of them on bottom. So this 1's going to be gone, and I'm going to have 2 left. So I have 3x minus 2, and once that's the only thing left, I don't need to put the parentheses anymore. The bottom is x minus 6 squared. And there's my final result. All right, so now comes to the part where we have to do some extra work ourselves. Let's see. So the worst part about these problems is the fact that you have to factor them yourselves. So now notice you have multiplication. So when you have multiplication, just when you multiply fractions, you multiply the numerators, you multiply the denominators, and then you reduce, right? So when I look at these problems, I'm going to go ahead and factor these. I got 5x and x. What multiplies to 8? Let me try maybe 4 and 2. So if I put, that's too small. I need to, it's a little bigger. Let's see. 5x and x. Let me see. Yeah, if I put 4 here and 2 there, because this is going to be a 10 and a 4, which is going to get me my 6 in the middle. So 10 is negative, 4 is positive. Over here, I want 5x and x, 28. Let's try 7 and 4. 7 here and 4 there is going to work because I'm going to have 35 and 4, which makes 39, all positive. Over here, 10 minus 6x. All I can do here is take out a 2, which leaves me 5 minus 3x. And on top, I have a 7x I can pull out. And that leaves me 3x minus 5. Okay. All right. So basically what you're kind of done here. But if you want to be kind of go the long way about it, what you're doing when you're multiplying is you're basically gathering all the things on top together. So we have a 5x plus 4, an x minus 2, we have a 3x minus 5, I'm going to put that 7x there, and everything on the bottom. So I have 5x plus 4, x plus 7, 5 minus 3x, and then put that 2 in front. All right, and so basically now it turns into one of the 4 problems we did earlier. And so you just start canceling. But, I wouldn't go and write this step out normally. I would just start, canceling these things up here. Okay, but just to show you that it's the same. So these cancel. These 2 cancel, but I put a negative. And I think that's it. 7 and 2 don't cancel. X plus 7 and x minus 2 don't cancel. So I get negative 7x and x minus 2 in the numerator. The denominator is 2 and x plus 7. And I'm finished. Now somebody might multiply these out if they want. That's just personal choice, but this is usually how you're going to see it done. All right. Here in this next problem, I see division. So division means that I'm going to multiply by the reciprocal, right? So this x minus 3 on top here, oopsie. It's already factored. In the numerator, I have, I can pull a 4x out, which leaves me with x plus 5, times, now we're going to, remember when you divide with fractions, you change it to multiplication, and the second one becomes the reciprocal, so it flips over. So x plus 5 goes up top, and on the bottom, I need to factor that as I go, so it's got to factor this. So 2x and x, if I put a 3 and a 1, all positive, that works out to 6 and 1, which makes my 7. All right, so let's try my canceling. So I don't have to write it as a one problem like I did here. I can just cancel it from here. So let's see, 2x plus 1, nice. X plus 5, nice. Ooh, x plus 3 and x minus 3, not the same. So the top's going to be x minus 3. The bottom's going to be a 4x and an x plus 3. And that is finished. All right, and number 7. Number 7 is what's called a complex fraction. So if you saw this problem, you could also very well see it written like this. You could see 18x to the third divided by 7, divided by, so I could write it like this, divided by 15x to the fourth over 14. So now, just like we did in the last problem, the second fraction flips over. So I want you to see it like this. I don't want to have to write this extra step. So you know that when you do this problem, the top stays the same. 18x to the third stays over 7, switches to multiplication, and it's the second fraction right here that flips over. So that 14 is going to be on top, right? 15x to the fourth. So you need to be able to switch it from this format to this format, and then go about your business. Let's see, 7 and 14 make a 1 and a 2. 18 and 15 divide by 3, so that's a 5 and a 6. And x to the third is gone, and leaves me x to the first. So my answer here is going to be 6 times 2, I got 12 in the top, and nothing else. The bottom is a 5x, it looks like. So there we go. All right, so let's practice what we just learned here. The top, I have a complex fraction. I have 11 minus w over 30 w squared stays, times the bottom one flips up. I got 5w to the sixth, and then w minus 11. All right, these cancel but produce a negative sign. Let's see, The 5 and the 30 make a 1 and a 6, and W6 and W2. The W2 is gone, leaving me with 4 here. All right, so let's see, I have a negative and a W to the 4th. In the denominator, I have a 6. And there's my answer. And let me make that a little bit better looking. Negative W to the 4th. All right, that'll do us.